Okay, class, today we're going to talk about scatter plots. The standard that we're going to look at is the one here in front of you, 811A, says construct a scatter plot and describe the observed data to address questions of association such as linear, nonlinear, and no association between bivariate data. So basically we're going to learn to construct a scatter plot by hand, okay, and on the calculator, and be able to answer questions about the scatter plot itself. There are certain properties that we have to abide by when we're dealing with scatter plots. So let's look at the first one here. The first thing that we need to know is that a scatter plot is a graph that uses points to display the relationship between two different sets of data. Each point can be represented by an ordered pair. So when you look at this scatter plot, it's talking about the ages and diameters of trees. So what you notice in this one, hopefully you notice, is that as the tree ages, as it gets older, it seems to be getting wider or fatter. The diameter increases. So as the age increases, so does the diameter. So what does this point here in the middle actually tell us then? Okay, so if we were to look at that particular point right there, we could find out that that point is a tree that is 25 years old and it has a diameter of 8 inches. And each point represents that. And what we're looking for in a scatter plot is, are there general trends? Okay, what can we expect from this? So if the tree kept getting older, what should we expect? The diameter to increase. And this kind of has a general positive relationship going. So as one increases, the other one increases as well. Right? And that's one of the things that you need to kind of understand about some of the data. That's what we're looking for. Okay, is how can I, what is the general trend that the data is telling us? The other thing that you're going to have to be able to do is be able to answer questions about a scatter plot. So what about this one? It says the scatter plot shows the ages and sleep times of several people. Use the scatter plot to classify each statement as true or false. Okay, so we're trying to figure out, are these statements here true or false based on this information? So as you look at the data of age and sleep time, it looks like, based on the information given in the chart here, that as you get older, you need less sleep. Okay, because it looks like there's a general trend of this data going downhill as you get older. So with that in mind, answer these questions. It says the first one, 2 people slept for 7 hours. Well, if we look at this label here is hours, this label is age. So what I need to do is go up to 7 hours and go across and see, are there 2 people that slept for 7 hours? And yes, there were. That is true. Okay, B, 5 people over the age of 12 were in the group. Well, this one we're answering questions about age, so we go to 12. We go up here and we find out here's our 12, but do I have 5 people over the age of 12? I have 5 people 12 or older, but because this one is 12, I only have 4 people that are older than 12, so this is a false statement. And then C, everyone in the group slept for at least 6 hours. So again, I go to the 6 hours, I go across, everybody is above that line. That is a true statement. So a few notes that I need you to take about scatter plots, a few things you need to know. First thing is, raw data isn't perfect. Okay, very seldom do we have good data when we're collecting real stuff. Okay, it's not going to be nice. Take for example, how often do you go to Walmart and your bill is to the even dollar? Okay, very seldom happens. Okay, so when we're dealing with raw data, we're looking for general trends. Okay, number 2, scatter plots are used to analyze raw data. Okay, so take for example, if I ask you the question, okay, a whole class, tell me what your height is and tell me what your shoe size is. Okay, it's going to be all different kinds of stuff, and it's not going to make a pretty little line whenever I'm graphing that information. It's going to be kind of all over the place, but you're going to see some general trends. As a person gets taller, their shoe gets larger. Right? Next thing, number 3, never connect the dots in a scatter plot. No matter how much we want to, don't connect them. And then last but not least, number 4, correlation. This is a big new word that we need to add into our vocabulary. Correlation is the word used to describe how the data is clustered or how it is related. How closely the 2 quantities are related to each other. That's what clustered means. So correlation is a look at how it's connected. What are the trends telling us? We're going to have 3 types of relationships to deal with. Positive, negative, and no correlation whatsoever. Okay, so let's look at some of the examples here. Positive correlation. You'll notice that each of these graphs is just like positive slope. Positive slope is going uphill, so is a positive correlation. Okay, so positive correlation, as one set of the data increases, the other set tends to increase as well. So we've got two variations of correlation, positive correlation. This is known as a strong correlation because they're all pretty tight together on a line. Okay, there's a general trend to be a line, but they're a little further apart, so it's kind of a weak correlation. And there is a measure to determine how related two items are. Right? Negative correlation. Well, negative correlation is the same as like a negative slope. Okay, it's going downhill. Same kind of thing. So this one says, as one set of the values increases, the other tends to decrease. So this one is going down, and this one is going down. Again, this one's kind of a tighter pattern. This one's a looser pattern. So this one's a weak correlation. This one is a strong correlation. And then you've got the last one, which is no correlation whatsoever. It's just kind of all over the place. The values show no relationship whatsoever. Okay, an example of this one might be, tell me how tall you are and tell me how much change you have in your pocket. Okay, those two things have absolutely nothing to do with each other. So let's see if we can kind of look at some examples and see if we can determine which one it is. Okay, so number one, do you see any kind of a relationship? No, this one is no relation. What about number two? Well, you see a general trend of things going down, so that means it's going to be a negative relationship. Okay, this one, you've got kind of a general trend of things going up, so that is a positive relationship. Okay, this one, you've got a tight grouping going up, so that's going to be a positive relationship, positive correlation. This one, tight group going down, so that's going to be a negative correlation. And then this one, no matter how much we want to connect those dots, does not seem to be any pattern. So this one is no pattern. Okay, does that make sense? Okay, excellent. So now let's look at a few scenarios. Okay, here it says identify the data sets as having a positive, negative, or no correlation between them. Number 8, the number of hours a person has driven and the number of miles they've driven. Okay, so the longer you drive, the more miles you drive. So this should be a positive relationship. Number 9, the number of siblings a student has and the grade they have in math class. Well, those have no bearing on each other, so that would be no relationship. The age of a car and the value of a car. Well, as a car ages, its value goes down. No matter what kind of a car it is, it does go down. Okay, so this would be a negative relationship. Okay, and you can do the rest of them by yourself if you'd like. Let's kind of move on then. Okay, so there's also some types of correlations that we need to look at. So if you look at these examples, these are what we call linear associations because they seem to lie on a line or form a line. But we can also have some patterns that they kind of curve. There's a general trend of this one that's kind of going like that, going up. This one's kind of a general trend here. So, as one increases, the other one, decreased some, and then it made a pattern of increasing. And this one, as one increased, the other one increased, but then it turned. Okay, so you can have some nonlinear associations as well. Okay, just to kind of make sure that you kind of understand those kinds of things. Now let's see if we can actually create one. Okay, so here is an example. All right, we're going to create this one twice. We'll create it the first time by hand, the second time on the calculator. Okay, it says a history teacher asked her students how many hours sleep they had the night before a test. The data below shows the number of hours the student slept and their score on the exam. Plot the data on the scatter plot. So the teacher's trying to determine, does more sleep before the test actually mean you'll get a better grade? So that's kind of the premise that they're looking for. So what we do here is we take these two values and we put them on the graph. So this one, hours of sleep, in this particular graph is representing our x-axis. Okay, and the test score is representing our y-axis. So that's our coordinate. So the first coordinate is 8, 83. So we come over here to 8, and we come up here to approximately 83, and we put a dot. Next one is 7, 86, 7, 74, 8, 88, 6, 76, 5, 63, 7, 90, 4, 60, 989, and 781. Now, if you look at the data there, it does seem to have a general trend in the positive direction. So that kind of shows, based on the data that we have here, that more sleep the night before the test does equate to a higher grade. Now, there's some probably other variables in there as well, but according to this data, it does show that more sleep does equate to a higher grade. Now, let's see if we can do this on the calculator. So let me bring up my calculator. Let me bring it into view here real quick so that we can see everything. Now, what we do to graph this is the same exact thing that we did by hand. Okay, the first thing we have to do is we've got to collect some data. We get the data and we put it into our calculator. And the way we do that is we go into Stat, our Edit, and we put in our data. Now, I've already taken the liberty of putting the data in to speed things up just a touch. So I've got my data in. The next thing I need to do is I need to set up my graph window. What does my graph need to look like? So I press Window and I look at my x-axis, and it was from 0 to 11 on our graph. Okay, so let me move that over to the side a little bit so we can see a little bit better. Okay, and have the calculator there as well. Okay, so you'll notice on the x-axis I go from 0 to 11. So that's what we're going to do on our calculator. I'm going to have my x-min at 0. I'm going to have my x-max at 11. X-scale says I'm going to count by ones. Okay, so I'm going to leave that as 1. Now, on our y-axis, we had a graph break right here. Okay, so I can start at 60, but I like to have mine be a little bit wider on the y-axis. So I'm going to start it at 50, okay, for my min, and I'm going to go all the way up to 100, okay, for my x. All right, now I use my scale. It says I'm going to count by 5s. Okay, so I'm going to use my scale as 5 there. Okay, so now what we need to do is turn our graph back on. Okay, so I'm going to come in here and I go into Stat Plot, which is where we're going to do our graphs. I'm going to turn the Stat Plot on to a 1. I need to turn that one on, so I press Enter to turn it on. I arrow down to the type. Well, the first one I want is this one right here, which is a scatter plot. My data is found in L1 and L2. So my X list is in L1, my Y list is in L2. So everything is good to go. So now all I have to do is press the graph button, and then I have a scatter plot. Now if I'd come back and get this one back, let me see if I can get this one back real quick with those points. So there's my points, and now if we look at our calculator, bring it back into view, you'll notice those two graphs look about the same. And that's how we construct a scatter plot by hand and on the calculator. Until next time.